All right, for this function notation problem, since it's f of 4, you're physically going to be plugging a 4 in for each of the x's here, making it negative 4 squared minus 5 times 4 plus 6. So you do the 4 squared first, making it 16, and then you carry down that negative. Minus 20 plus 6, then you just go left to right. So that becomes negative 36 plus 6, or negative 30. All right, this is a system of equations, so you actually could solve by graphing substitution or elimination. I tend to lean towards substitution, so I'm going to actually minus that 7y over. So what I get is x equals negative 4 minus 7y, and I'm going to plug that in for x. So it'll look something like this. And then I'll distribute that negative 4 in. And then at this point, I'm going to put my like terms together. I'm going to do it all in one step to make it a little bit shorter. So if I put my y's together, I end up with negative 22y. And then if I add that 16 over to the 6, I end up with positive 22, giving me negative 1 for y. So once I get negative 1 for y, I can just come straight up here and plug it in for that y, giving me negative 4 plus 7, or a 3. So your answer would be 3, negative 1. All right, this is a system of equations in 3 variables. So the first thing you're going to want to do is create your graphic organizer, and then the first 2 equations actually just get carried over. And then the second 2 get carried over. Make sure you're checking your work as you go on this one, because it's really easy to make a mistake on these really long problems. So I'm going to cancel z's because it looks like right over here my z's will cancel on their own. So if I cancel z's there, I end up with 6x minus 3y equals 9. So then that 2 variable equation comes right over here. And then I'm going to cancel z's here. So I'll have to multiply this one by a 3. And then add down. So it looks like I'm going to get 17x minus 14y equals 9. So from here, it looks like I'm just going to cancel my x's. So I'm actually going to multiply the top times 17 and the bottom times a negative 6. I'm just going to multiply them times each other because I don't really know the common multiple between a 6 and a 17. So I'm going to end up with this. And then, let's see, multiply the negative 6 in. And then if we add down, those x's are going to cancel. Oh, that should have been a positive right there. The x's are going to cancel, giving me 33y equals positive 99, or y equals positive 3, which looks right. So then that y, I can plug it into either one of the equations. And if you plug it in, you're going to get x is 3. And then what you do from there, then if you plug the x is 3 and the y is 3 in, you're going to end up getting a z is a negative 2. So your answer is, if you put it in the correct order, is going to be 3, 3, negative 2. Just like that. All right, you guys have seen this problem before. So basically you're setting up a system of equations, and since you're not mixing anything and you don't have any rates, you're just going to translate your sentences. So your first sentence right there talks about Barb. So she was charged $111 for 3 days and 300 miles. So that gives you your first equation. And then your second equation is right there in that line with Mark. He was charged $205 for 5 days and 600 miles. Now this becomes a system of equations since you're solving for 2 variables. So you can do substitution, elimination, or graphing. I'm going to do elimination because I'm going to multiply this by negative 2, and it's going to cancel my miles. So it's going to get me negative 222 negative 6d, negative 600 miles, and then when I add that down, I end up with negative 17 equals negative 1d, and that's gone. When I divide that negative 1 over, I get $17. So the daily rate is $17, and that's half of my equation. I can take the 17 and plug it in anywhere. I'm going to go ahead and just plug it back into that very first equation, which was the 111 one. So instead of d, I'm going to plug in 17, since I know that that's what it is. That gets me 51, and when I minus that 51 over, I end up with 60 equals 300m. When you divide that over, you get a decimal, 0.2, in other words, 20 cents. So your daily rate is $17, your mileage fee is 20 cents per mile. So these are our monomials. And the first thing you want to do is get rid of parentheses. And the way you're going to do that is distribute that negative 2 in. So you're going to give the negative 2 to each base. So you're going to give it to the p, the q, and the 3. And remember, we multiply it in. And then I'm going to do the same thing over here, but it's a positive 2. It's going to become n to the positive 2, p to the positive 10, q to the positive 8. And then I'm going to want to take everything that's negative and move it to the bottom of the fraction. So in the top of the fraction, I end up with 9 squared, or 81, p to the 10th, q to the 8th. In the bottom, I end up with 3 squared, or 9, p to the positive 6, q to the positive 12. At this point, we just put our like terms together. So numbers with numbers, 81 divided by 9 is 9, p's with p's, p10 divided by p6, we've got 4 extra p's in the top, and then q8 over q12, we've actually got 4 extra q's in the bottom, and that's your answer. So this is function notation again, and I get 2 things from the problem. I get the plus, meaning we're adding them, and I get the x, which means basically don't plug anything in, just keep x. So what I'm actually going to do is take f of x, which is 5x minus 4, and I'm going to add it to g of x, which is negative 8x squared minus 10x plus 7. And remember, when we add polynomials, we just put like terms together and we go in descending order. So the x squared comes first. He has nobody to go with, so he comes down by himself. And then we put our x's together, that's a negative 5x, and then we put our numbers together, which is a positive 3, and that would be your answer right there. Okay, we've got another function notation problem, and this is actually a composition of a function. This is g of f of x. The other way that you guys might be familiar with seeing it is like that. Sorry, g of f of 6. So remember, when we have composition of functions, we always start with the innermost first. So what I want to focus on first is f of 6. And what that means is take a 6 and plug it into f. So if I take a 6 and I plug it into f, I actually get 6 squared plus 3 instead of x squared plus 3, which is 36 plus 3, or 39. So instead of g of f of 6, I actually have g of 39, since f of 6 is 39. Now this is telling me to plug 39 into g. So I would go into g and plug 39 in, just like that. This is 78. Plus 5 is 83. So then your final answer would be 83. Okay, another composition of a function, f of g of x. Remember, we start with our innermost first. So g of x, I actually know what that is. So instead of g of x, I'm actually going to replace g of x with x minus 1. So instead of f of g of x, it's f of x minus 1. And what this means is take x minus 1 and actually plug it into f. So I'm going to physically go in here into f, and for every x that I see, I'm actually going to replace it with an x minus 1. Now we need to simplify this problem, so the first thing we need to do is take care of this x minus 1 squared. And remember, x minus 1 squared is x minus 1 times x minus 1. So doing this quickly, it's going to be x squared minus 2x plus 1, once I FOIL all that out and put my like terms together. And then in the same step, I'm going to go ahead and distribute that negative 3 in, giving me negative 3x plus 3. Now I'm going to distribute this 3 in. And from here, it's just a matter of putting like terms together. So my x squared would come first. My x's, I've got negative 6, take away 3 more is negative 9x. And then my numbers, I've got 3 plus 3 is 6, and 6 plus 7 is 13. And that is my answer. This is just a multiplication of polynomials, which we just use our distributive property. So 3x times x is 3x squared, and then 3x times 5 is negative 15x. Now we've got to go back and do it again with the 7. So that becomes 7x, and then that becomes a negative 35, and then we need to put our like terms together in the middle. That's actually a negative 15 plus 7, so it's going to be a negative 8x I can get my pen, and then minus 35, and that's your answer right there. This is your long division problem, and if you remember, for long division, the first thing that you need to do is actually set it up. Now you're going to use this x to try to cancel your first term. So x times what is 2x cubed, 2x squared. And then you take that 2x squared and you multiply it down, right? So 2x squared times x is 2x cubed. That's what we wanted. 2x squared times a negative 4 is negative 8x squared, and then we subtract. So 2x cubed minus 2x cubed is gone. And a negative 5x squared minus a negative, well, this minus a negative ends up being a plus, and we get positive 3x squared. Now we start the whole process over again, but now we're trying to cancel the 3x squared. So x times what equals 3x squared? Well, 3x. And then we multiply it down just like we did with the 2x. So we get 3x squared and negative 12x, and we subtract. So those cancel. Minus minus becomes a plus. We get 7x. X times what equals 7x? Well, 7. Multiply down. Subtract. That cancels. Minus minus gets us a plus. And we have a remainder of a 5. And the way that we write the remainder is we put the 5 on top and the divisor, or the x minus 4, on the bottom. Remember when we factor, first thing we look for is a GCF. This happens to have a GCF. The GCF is 12z. So you look for the biggest number that you can divide both of them by, and then when you look at your variables, you look for your variable to the smallest degree, leaving me z minus 2. I actually know that I'm done at this point because there is no squareds left. Everything is linear, so it can't be factored any further. Okay, factoring once again. First thing we need to look for is a GCF. Well, between a 25 and a 36, there is no GCF. So the next thing I look at is how many terms I have. Well, I have 2 terms. So my options are difference of squares, difference of cubes, or sum of cubes. Well, obviously it's not sum of cubes. That leaves difference of squares and difference of cubes. And since my exponents happen to be squared, so there's a good chance this is difference of squares. If you remember correctly, the way that we do difference of squares is you set up your answer, and then since it's difference of squares, you square root. So 25k squared is 5k and 5k, plus minus 36j squared becomes 6j and 6j. Now I know I'm done because everything's linear and there are no squareds left. Factoring, once again, first thing we have to look for is a GCF. There is no GCF, but there is a negative sign out in the front, and we have to get rid of that negative sign when given. So when you factor out that negative 1, it ends up changing all the signs of everything else. Now I know I'm not done factoring because I still have a squared. So what I do is I notice that I've got 3 terms, so I'm either going to use the box or the shortcut, and in this case, and on your final, you're going to end up using the box. There's going to be a number in front of that first term. So I'm going to set up my box, putting my first and last terms in. Now I need 2 numbers that are going to multiply to a negative 156, which is 2 times negative 78, and add to a 1, which is that middle term. So let me say that again. 2 times negative 78 got me 156, and there's where my 1 came from, is right there. If you go through your multiples of 56, 1 times 56, 2 times whatever, 3 times whatever, 4 times whatever, you will find out that 12 times 13 equals 56. And I know that I can get a 1 from that if I put a negative sign on my 12. So 12x and 13x become my 2 middle terms. And from here, we're going to pull out our GCFs. So these have an x in common, and these actually have a 6 in common, a negative 6 in common. These have a 2x in common, and these 2 actually have a 13 in common, giving me my answer of x minus 6 and then 2x plus 13. Don't forget to carry that original negative sign down as part of your GCF. That becomes part of our answer, and then we're finished. Last but not least, this is factoring. Again, So we start out looking for GCF. There is no GCF. I notice I have two terms, giving me the option of sum of cubes, difference of squares. It's not sum of cubes because it's not a plus. It's not difference of squares because I don't have any squares. I actually have a cubes. This is difference of cubes. If you remember, for difference of cubes, we actually need an x and a y term so we can fill it into our formula. So the way that we get our x and our y is, since it's difference of cubes, we now cube root. So the cube root of y cubed becomes y. The cube root of 64 becomes 4. Your formula for difference of cubes is x minus y. So let me write down the formula. It looks like this. It's minus plus plus, so you just fill it in. So instead of x minus y, this in our case would be y minus 4, because here's our x and here's our y. Instead of x squared, it's y squared. Instead of x times y, you just multiply them, and it's 4y. And then instead of y squared, it's 16. And there's your answer. Now remember, for difference of cubes, I realize there's still a squared right there, but you can't factor that any further. It's just common knowledge.